Good morning all, and welcome to this morning's training session. We'll be looking at FAAC PE beams, talking a little bit about how they work, and hopefully answering any questions you might have. As always, you guys as my audience are muted today, but any questions you have, please just type into the chat box and I'll try and answer them as we go along. Failing that, we will have a Q&A at the end of the session. Today's session won't be that long, so bear with me and hopefully I won't bore you too much. So let's start off at the beginning. Looking at our agenda, we'll look at the purpose of PE beams. We'll look at some PE beam basics, just look at some of the principles behind them. Then we'll look at the two most common FAAC products, the XP20 and the XP30, and then we'll have time for some questions and answers if there are any. All right, so why PE beams? What is the purpose? Very simply put, to protect life and property. So I've got a short video here just to illustrate those 2 points for you.
Got the whole screen, man. Oh, you missed that one, big boy.
Okay, so I think you can clearly see there are two instances regarding life and property. Obviously, when you've got gates, you've got moving objects. Moving objects have risk with them. Either a vehicle is going to get hit, a person is going to get crushed. So we always will recommend PE beams as part of a standard installation. I know there are cases where guys don't use them, but generally you should be putting them onto every one of your automations. Okay, so firstly, sliding gates. Typically, the installation of PE beams and sliding gates relate to a closing safety beam, as indicated in the highlighted arrow. So there's a set of PE beams across the driveway, and that's going to prevent that gate from closing onto a vehicle or person. There often is application for another set of either opening or closing safety beams on the opposite side of the gate. So it all depends on how well you want to protect, and whether you're protecting against the gate closing onto people and vehicles or possibly opening onto people in particular. So there's scope really for two sets of PE beams on a sliding gate, although in reality most of our installers will only be fitting the first set, which is on the actual the line that the gate runs to protect against the gate closing onto people or property. So as you can see here, the closing safety beam really just protects that vehicle's coming into the property is breaking the beam, and the gate will then not close onto the vehicle. You can have the same on the other side of the gate if you really want to protect comprehensively, as well as to protect on the opening side of that gate as it opens to make sure it doesn't hit anybody. Possibly you've got an application on a child care or somewhere where there could be children playing. You want to prevent that gate from opening onto somebody. In the case of swing gates, it's a slightly more complex situation because the swing gate obviously swings or describes an arc into the property. And so we would typically have a set of closing safety beams on the hinge line of the gates, as well as a set of opening and closing safety beams inside the property, just beyond the tips of where the gates swing. So in that case, as you can see here with the illustration vehicle, the closing set of safety beams prevents the gates from closing onto that vehicle. If the vehicle's in the driveway, either one or both of the sets of closing safeties prevent again the gates from closing. And in the case of the opening safeties, if the vehicle approaches too closely to the gates when they're open, they will also prevent the gates from opening onto the vehicle. Something worth bearing in mind is the height considerations of the PE beams. Depending on the vehicle, depending on the traffic typical to the site, you may require what we call dual height beams. So in other words, two sets of beams which are connected effectively in series with each other, so that if that first lower set passes under a vehicle, a very high vehicle, or in fact, if the top set of beams passes through the windows of a lower vehicle, the second set is going to be obstructed. So there are applications where those dual height beams are suggested, and they will very much vary from site to site, as I say, depending on the type of traffic. All right, so let's look at some PE beam basics. That's photoelectric beam basics. The most simple system, and one that you often do see out there, is called the reflective PE beam. And in this case, you have a transceiver, which is shown on the left, and you just have simply a reflector, which is shown on the right. The principle of operation here is that the transceiver sends out a beam of light from its transmitter. That then reflects off the reflector back to the transceiver and is received by the receiver side. And as you can see from that green tick says, okay, all good, the entrance is clear. The benefit, obviously, of this system is that there's only one active component, and that's the transceiver, which is on the left-hand side here. The far side of the driveway, that reflector is it's basically just an inert piece of equipment, doesn't need power, and just simply reflects the beam of light. As the vehicle approaches now, breaks that beam of light from the reflector. As you can see, the beam does not get back, and so the transceiver indicates with that red cross, yes, there is an obstruction, something is in the way. And as the vehicle drives off, so the beam is restored. The danger with the reflective type system, and this I've seen firsthand, the shiny, nice sports car comes along and approaches a little bit too close to that transceiver. The actual beam of light reflects off that shiny surface back to the transceiver and says, everything's okay, and then the gate closes onto the vehicle. So this is something just worth bearing in mind with the reflective PE beam. They are attractive, I understand, because you've obviously got no active component on the far side of the driveway, but they do suffer from this potential issue. And we do, as you'll see later on, offer wireless or half wireless solutions which overcome the need to have power on the far side of the gate. So that takes us on to the next type of beam, which is a transmissive PE beam. And this is typically how the beams we sell work, and how many of the beams you'll come across also work. In this case, you have a transmitter and you have a receiver. The transmitter transmits a beam of light across to the receiver, which receives it and says, okay, thank you, green tick, all good, nothing in the way, the gate can operate. In the event that a vehicle does come along, obviously breaks that beam, the receiver indicates, I've lost my beam of light, and do not operate the gate. So that gives you the safety aspect. Something else I want to look at here is the importance of the lens in these PE beams. So the purpose of the lens is twofold. On the transmission side, or the transmitter side, within the transmitter there is an LED which generates effectively a beam of light. It's a light source. Now that beam of light is generally quite wide and scattered, and the purpose of the lens on the transmitter is to gather that light together and form it into a nice parallel, what we call collimated beam of light. So that's a nice tight beam of light that then effectively gets sent across the entrance. On the receive side, conversely, that nice collimated beam of light comes in, and that needs to be focused very tightly onto the receiver element of that beam receiver to ensure that you're concentrating. You must remember that this light is obviously crossing some distance, anything from maybe 2 or 3 meters up, in extreme cases up to 10 or 20 meters. And that light tends to sort of dissipate and become blurry and fuzzy. And we want to really focus whatever light is left onto that receiver so we can sense it in a very positive way. And that's the purposes of the lenses on both the transmitter and the receiver. So those lenses are actually critical. And we'll see later on why you need to ensure that those lenses are in place when you are setting up the system. The second thing to understand with PE beams is how the light actually works. What type of light is used? Because if you look at these PE beams, even if it's at night, you don't see any visible light crossing the driveway. Often in movies, you'll see this red beam of laser light. And in the case of these PE beams, we don't operate in the visible spectrum. You can see there the visible spectrum, which is typically the colors of the rainbow that we're all familiar with, running all the way from red on the longer wavelength end to violet on the shorter wavelength end. These particular beams, generally PE beams, operate in the infrared range, so around the 800 nanometer wavelength. This is not visible to the naked eye. So we then need to worry about how visible light, for example, the sunlight and the daylight around us, can possibly affect the PE beam. And the way we get around this is using what we call a visible light filter. So effectively, we put in place a mechanism of filtering visible light. So there you can see on the bottom left, the sun shining, that light comes in and hits this filter. And that filter basically blocks the light out. So the sensors inside the beam do not even see that visible light, or if they do see it, it's very, very dim. Whereas on the top, the infrared light from the PE beam transmitter actually passes directly through the filter and gets to the receiver. And you might ask, well, where is that filter? What is that filter? That filter generally is a dye or a pigment that is included in the housing of the PE beam. So when you look at the PE beams, they're generally very dark. In fact, they look black. They look like they're in fact opaque. In other words, that light doesn't go through them. But if you hold them up to the light, you'll actually see quite clearly. You can see through them. It's just like a very, very dark pair of sunglasses. And so that pigment that's in the casing is actually there to largely prevent visible light from interfering with the reception of that infrared signal. All right, so the next thing, or the last thing we'll actually look at here, is the output contacts. So in other words, we need to have some way for these PE beams to indicate to our electronics, to our control boards of our gate motors or our alarm systems, wherever we're using them, that in fact that beam of light is received and intact and nothing is in the way. And so for fail-safe operation, we generally use a normally closed contact. So you might ask, why a normally closed contact? Well, I'll touch upon that in a moment. There you can see the transmitter and receiver pair with a beam of light successfully between them. And you can see on the right-hand side, the contact is closed. As a vehicle comes in and breaks that beam, the contact opens. So you take the vehicle away, contact's closed, bring the vehicle in, the contact opens. So we use a normally closed contact. We call that a fail-safe contact, because what that means is that if for some reason the wiring or the cabling gets damaged, somebody puts a spade into the ground and chops the wire, or the wire wears over time, it always fails in a safe mode. So in other words, if the wire is broken, the beam is sensed as obstructed, and so the gate will not close. So generally always normally closed. The one thing to bear in mind, though, when you are working with normally closed contacts, is that if you're using multiple PE beams, and we use multiple PE beams, as we've seen often with dual height beams, or there might be, maybe a light curtain you're trying to implement, you always need to wire those contacts in series, as shown here. So basically one through the next, so that if any one of those contacts opens, the circuit is sensed, rather than connecting them in parallel as you would do with, let's say, a gate trigger. So always remember, multiple PE beams contacts, normally closed contacts, need to be wired in series. Okay, so moving on, the last thing I want to look at just is some mounting tips. You want to ensure that the beams are mounted onto flat parallel surfaces, and you need to shim them if necessary. So you really want these two elements of the beam to roughly point towards each other. So although they have beams and they've got a degree of self-alignment, you really want them pointing as close as possible to one another. As you can see here, the transmitter's pointing upwards, the receiver doesn't receive the beam. The transmitter's pointing downwards, the receiver doesn't receive the beam. Get it nice and parallel, the receiver receives that signal. It's not super critical, but it's important to be aware of. And obviously, the longer the distance you're working over, the more important that becomes. Okay, so let's quickly look at the XP20W, which is our standard wireless photo beam. It has a nice feature in that the internal elements can be adjusted with 180 degrees. So you can actually rotate that inside element so that the unit can work basically through a plus or minus 90 degree range. And the benefit here is that if you cannot mount the beam onto the front face of the gate post pointing across the driveway, you can actually mount it pointing into or out of the property and then rotate the internal components 90 degrees to actually face across the driveway. The internal component, as you can see here, actually does have the lens integrated into it, and the entire casing of the unit, although it looks black, is in fact transparent to infrared light. It's that light filter, that visible light filter I was referring to. So as you can see in the right-hand diagram, the internal components can actually be rotated to point anywhere between the plus or minus 90 degrees. Very handy for installation. The transmitter, in the case of the XP20, can be battery powered. It uses a CR2 3-volt lithium battery, but can also be wired if you've got cabling to the far side. And the benefit of wiring, as you'll see later in the specifications, is it gives us a little bit additional range. If you are using the battery life is going to be in excess of 2 years. So in general, a fairly good life, although it is a fairly specialized battery. So they are available, but obviously not just available in every corner supermarket. The other benefit of the XP20 is we offer multiple channels. So what that means is in the event of a number of PE beams being mounted in a vertical configuration, let's say, 2 of them for dual height beams or up to 4 in a light curtain application, often in normal situations, these beams tend to interfere with each other. So the top beam on the left, tends to interfere with the beam slightly below it on the right. In the case of the XP20, we offer multiple channels. So what that basically means is we can set up the top beam to be on channel 1, the next one channel 2, the next one channel 3, the next one channel 4, etc. And the benefit of these channels is it prevents crosstalk or interference between sets of PE beams that are mounted in close proximity to each other. So that's a really, really nice benefit of the XP20. In terms of the specifications, there we can see the 2 elements on the right-hand side, the receivers on the left and the transmitters on the right. The power supply for the receiver, 12 to 24 volts DC or AC, and the consumption there around 30 milliamps. The power supply for the transmitter, either again 12 to 24 DC AC at 5 milliamps, or the CR2 battery. Obviously, if you're using the battery, there's no need to run wires, and that's the wireless element. The receiver output only offers a normally closed contact in this case, so that might be a bit limiting if you want to use this as an exit beam or a free-to-exit beam because you don't have a normally open contact. But the majority of times that the XP20 is used is in a safety application where you need that normally closed contact. The operating range on the XP20, as the 20 indicates, is 20 meters. That is if the transmitter is wired. And this is an important point to note. If the transmitter is being used wireless, the range of the XP20s is 10 meters. And then lastly, there is the mechanical adjustment, the plus minus 90 degrees that I mentioned earlier, which is quite handy when you want to mount the beams around the corner. There are some LED indications on these boards. So the first is on the transmitter, there is a power indicator, and that is always on when there's power, except if you're running off battery. If you're running off battery, that power LED is always off, and that's obviously to save life on the battery. There is a second LED DL2, which is used for channel programming, and we'll talk about that in a moment. On the receive side, there is a dedicated power on LED that is always on, obviously, if power is present. There is a second LED DL2, which is used again for channel programming and also to indicate that the battery on the transmitter is okay. So that gives you an indication of the battery level. And then thirdly, we've got a third LED, which shows alignment. So that basically indicates are the actual PE beams aligned suitably to work reliably. Let's talk a little bit about programming the transmission channels. We spoke about that, and this sometimes does cause a bit of confusion. There are there's a push button on each of the elements, the transmitter and receiver. So on the transmitter, push button 1, you basically press and hold that push button down for a couple of seconds, and then LED DL2 will actually start to flash. And it either flashes once with a pause, twice with a pause, 3 times with a pause, or 4 times with a pause. And it will flash that repetitively a couple of times before turning off. And that 1, 2, 3, or 4 flashes is an indication of the channel that transmitter is using. And it's important that whatever channel that is must be the same between the transmitter and the receiver, otherwise they will not communicate. In many cases, I'll get PE beams back where the customer says to me they don't work, and we actually find they're set to different channels. On the receive side, the same thing. There's a push button for setting the channel. Again, you press and hold that down. There's an LED that flashes once, twice, 3 times, or 4 times to indicate the channel. And again, just to reiterate, you basically want to assign a different channel to every pair of photocells in the system that are located close to each other. If the PE beams are nowhere near each other, there's no need to change the channels. Leave them at the default, which is channel 1. It's only when you're operating beams that are close to each other and could interfere with each other that you want to be changing the channels. And then again, the channels on each matching pair must be set the same. Okay, let's move on to the second type of XP20 beams, which is the XP20B, which is the bus version of the photo beam. So those will work directly with the bus 2 easy connections on things like the E024, E124 control boards, E045 and E145, etc. The benefit of the bus photo beams is that they basically just a 2-wire system, and it's very, very simple to use. So you can connect these devices up to the bus connector on your control board over a distance of up to 100 meters. They are polarity insensitive, so they don't really matter which way around. They get wired, which makes them really, really easy to use. They allow up to 16 dip switch configurations. So each of these receivers and transmitters of the bus PE beams have a set of 4 dip switches, and they allow you to configure the PE beams with up to 7 closing pair of beams on the bus, 6 pairs of opening beams, 2 pairs of opening and closing beams, and 1 set of beams to generate an open pulse, in other words, a free to exit. So as you can see with these bus PE beams, you can wire up to 16 sets of beams onto the same bus system. I mean, I know that that's crazy. In most cases, it would never be used, but it's a really, really easy way of implementing, let's say, for a swing gate, a number of sets of safety beams for both opening and closing and for free exit. The bus PE beams are wired, and so they have an operating range of up to 20 meters. Once again, because they're in the XP20 format, they do allow the mechanical adjustment of up to 90 degrees. Okay, in terms of LED indicators, once again, we do have some LEDs. On the transmitter, there's an LED that indicates the bus status, whether the bus is correctly connected and working. On the receiver, there is an alignment indication as well as a bus status indication. So again, it makes it quite easy to work with and troubleshoot in the field. Let's look a little bit at the dip switches on these products. So we spoke a moment ago about those dip switches. 4 dip switches, which offer us up to 16 different dip switch configurations. And these allow basically 7 pairs of closing beams. And as you can see, there are the 7 dip switch settings for the different sets of closing PE beams. Obviously, each pair that you're using has to have the same dip switch settings. In essence, it's like the form of a channel. So you've got 7 closing channels. We have 6 sets of opening channels. Again, those are the dip switch configurations for the opening channels. We have 2 sets which can be used for both opening and closing. So they would be typically the set that you use at the tips of the gates in a swing gate application to protect both opening and closing safeties. And then lastly, all the dip switches on 1 pair of those, which is just to generate an open A trigger, an open pulse to the gate system. All right, let's move on to the second type of PE beam, which is the XP30. As you can see, they look quite different. These are available, incidentally, in both stainless steel, which is shown on the left-hand side of that image, or in just a black plastic. One thing you need to notice that's quite important here is that there is no adjustability, and there's also no lens fitted on that circuit board on the right-hand side. We'll touch on that in a moment. Once again, we offer multiple channels, so I won't spend too long there, but basically channel 1, channel 2, channel 3, channel 4, these multiple channels are available on the XP30, so once again, allowing you to have multiple height beams or beam curtains with no interruption between different beam elements. Importantly, as I point out here, the lens on this product is actually in the cover. So here you see the example of the black plastic covers. The lenses are actually built into the cover, which means the lens is not there when the cover is off the product, like in the XP20. In the case of the XP20, with the cover off, you still have the lens present. Over here, the lens is not present. So for alignment purposes, you want to be sure when you're installing these beams and trying to get them working that you do have those covers fitted, because that not only gives you the light filtering, but also gives you the lens, which, as I've mentioned, is really important, particularly when you're working at the longer distances. In terms of specifications for the XP30, power supply similarly to the XP20, 12 to 24 DC AC at 30 milliamps. Same on the transmitter, 12 to 24 at 20 milliamps. So this takes a little bit more current than the XP20s, but that's because it's an XP30, which is giving us, as the 30 indicates, 30 meters of range. The receiver here has a normally closed and a normally open contact. So that gives you the ability to have both safety or free to exit. The operating range, as I mentioned a moment ago, 30 meters here in the case of the XP30s, and no angular adjustment on this product. In terms of LED indications, these LEDs are blue in color and operate as follows. On the transmitter, both of those LEDs show you the power is on. They're also used for the channel programming, so they will flash while we're programming the channels. On the receiver, we have an alignment and channel programming LED. We also have a power on and a channel programming LED. Programming the transmission channels on the XP30 is exactly the same as the XP20. There's a dedicated push button. I'm not going to go through the details here, but basically press and hold the push button to cycle through, watch the LEDs, and select channel 1, 2, 3, and 4. Same on the receiver. And once again, assign different channels to each pair of beams and make sure that each pair have the same channel assigned to them. We also have a bus version of the XP30, as you can see on the right-hand side there. So very similar to the XP20, the same principles apply. We have a maximum of 100 meters of cabling on the bus, polarity insensitive. We have a couple of LEDs indicating the bus status and bus power, as well as alignment on the receiver and bus status and power on the receiver. Once again, same dip switch arrangement. So if you're familiar with the XP20, same for the XP30. Pretty much 7 sets of closing beams, 6 pairs of opening beams, 2 pairs of opening and closing beams, and 1 pair for open pulse or open A trigger. So that pretty much covers the beams, both the XP20s and XP30s, which then brings us up to some Q&A. So what I'm going to do now is I'm just going to quickly unblock our participants, unmute you all, and allow you, if possible, to answer any, to ask any questions. You're all unmuted. I can hear you all now. So if you guys have any questions, please fire them at me.
How's all good, Ian?
All good. Okay. So no questions there. Anybody else have anything? Alrighty. So look, as I say, this was a bit of a brief rush through the PE beams. Again, if you have any issues as you use them, as you work with them, we're always available. Give us a shout at any time. And thanks again, once again, for your time, guys. It's always a pleasure to host you, and hopefully there was something you learned this morning. And I look forward to seeing you in our next session in a fortnight's time, where we'll be looking at the E124 controller. Otherwise, have a great day.
See ya. Bye.
See you. Have a nice day. Thanks very much.
Great. Thanks, mate. Cheers, and bye-bye.